Hi there, grade 8. I'm going to discuss factoring, and that's lesson 6 of unit 1. So before we work on factoring, let us recall how do we work on GCF. So when we say GCF, we call it, or we consider it as the greatest common factor. So let's work on the following exercises. Number 1, so in each item, we are asked to find the GCF of the following numbers. So the question is, how do we work on the GCF of each number? So what we're going to do is to list down each number and then place the prime factors of each number on the same row. Like for 18, we know that 18 eh, when divided by 2 equals 9. When 9 when divided by 3 is 3. So these are the factors, prime factors. So we have 2 times 3 times 3 with 21. So when 21 is divided by 3, we have 7. So the factors of 21 are 3 and 7. So we will place 3 along with this column, since 3, this factor 3 is the same with this factor 3 of 18, and then we'll place 7 here on a different column, but take note here that 3 and 7 are placed on the same row. And lastly, for 27, we know that 27 is a perfect cube. So this is like when 27 is divided by 3, the resultant is 9. So when 9 is divided by 3, it's 3 again. So these are the factors. So we have 3 here, and then another 3, and then another 3. So 18, 21, and 27 has only one set of common factor, which is 3. So therefore, we consider the GCF of the numbers equal to 3. For the number second example, so factors of 45 are 5 and then 9. When 9 is divided by 3, we have 3 here. So we have 3 times 3 times 5. Now with 75, we have, when 75 is divided by 5, we have rather 3. So we have 25, and then 25 is divided by 5. This will result to 25. So the prime factors for 75 are 3, and then 5, and then another 5. For 90, we can start with 2. When 90 is divided by 2 is 45, and then 45 divided by 5, it's 9. 9 divided by 3 is 3. So we have 2 times 5 times 3 times 3 for 90. So we'll place this 3 here, and then another 3, and then the 5 factor, and then 2 here. So as you can see, they have two sets of common factors, and these two sets will be multiplied, and that will be their GCF. So their GCF is equal to 3 times 5, which is 15. Now the question here is, how do we work on the GCF for algebraic expressions like 121a cubed b squared and 99a squared b cubed? So same with what we did in the previous examples. For 121, we know that this is like 11 times 11. Now we will factor out the variable. Like when we say a cubed class, this is a times a times a. When we say b squared, this is b times b. Now with 99, so this is 11 times 9. And then a squared is a times a, while b cubed is b times b times another b here. So we'll get their common factors, like we have 11 here, a, another a, b, and another b. So their GCF is 11 times A times A times B times B. So this is 11 A squared B squared. Now, how do we work on the GCF involving algebraic expressions? We're going to consider the least exponent. For example, between a cubed and a squared here. So the least, or 2 is less than 3. So we'll consider a squared as one of the GCFs. With b squared and b cubed, 2 is less than 3 here. So we'll consider b squared. So that's how we work on the GCF involving algebraic expressions. Now, why we recall GCF? Because the basic idea or the basic step in finding the factors of polynomials class is working on the GCF. Whenever you do not see any pattern on the polynomials and you are asked to factor completely, for instance, we do not know yet any patterns in factoring, so we will start first with the basic one, and that is working on the GCF. That GCF class will be considered as one of the factors, and the other factors will be obtained by dividing the given by the GCF. So let's start by working on the GCF among the three terms here. So from the numerical coefficients, we know that 13 is the GCF. And then among the algebraic expressions, so we consider the least exponent uh, with x. So we have 1 here. So this is x. And then for y variables, we're going to consider y. And then the exponents among z variables, so the least value is 1, so this is z. Therefore, the GCF for this polynomial in number 1 is 13yz. Now, to obtain the second factor, what we will do is to divide each of these terms by the GCF. So we'll get the second factor. So we are like dividing the first term, 39 x squared y cubed z, by the GCF 13xyz. So you have to recall the law of exponent. So first you have to divide their numerical coefficient. So this is 39 divided by 13, we have 3. Then x squared divided by x. So this is like subtracting the exponent. So this is 2 minus 1. So this will be cancelled. There remains x to the first, or simply x. 3 minus 1 for y. So this will be cancelled, but this becomes 2. And then both c here will be cancelled. So as a result, what is the remaining expression when the first term is divided by the GCF? So we have 3x squared y. Now we will divide the second term, 26xy squared c squared, by the GCF again, 13xyz. So we have 26 divided by 13 is 2. So both x will be cancelled here. 2 minus 1, so this will be 1. And then 2 minus 1 for z, we have z here. So the remaining expression will be 2yz. So this is plus 2yz. And then lastly, negative 13y xyz divided by 13xyz. So this is negative 1, because everything will be cancelled when you divide 13xyz by 13xyz. Take note that this is negative. We have to carry on with the sign of the last term. and everything is canceled here. So this is like 1, but there's a negative here. So this has to be negative 1. So class, these are the factors. So when you multiply the two factors, you go back with the given. In that case, your answer is correct. So again, we're going to work on the GCF between the two terms. So the GCF for that would be 7. So we have 7m and then n squared. So this is the GCF. Now, the next step for us to know the second factor of this polynomial function, we're going to divide each term here by the GCF. So this is 49 m cubed n squared divided by the GCF 7m n squared. So 49 by 7 is 7. Now 3 minus 1 is 2, and then n squared are cancelled. So the result is 7m squared. So this is 7m squared. And then minus, so this will be divided by the GCF. So we have 63m n cubed by 7m n squared. So 63 by 7 is 9. And then m and m are cancelled. This will be cancelled. 3 minus 2 is 1. So this will be n. So we have 9n. So this is minus 9n. And these are the factors. So for number 3, so what will be the GCF for this? So it's 16j k squared. Now we will divide both terms here. Like we'll divide 64j cubed k squared by the LCD 16, rather the GCF 16j k squared. So 64 divided by 16 is 4. And then j cubed divided by j, so this becomes 2. And this will be cancelled. So k squared will be cancelled here. So we have 4j squared. And then the second term, 16j k cubed, will be divided by the GCF 16j k squared. So 16 by 16 is 1. J divided by j is 1. Now 3 minus 2 for k. So this will be cancelled, but this becomes 1. So the remaining expression is k. So this is plus k. And these are the factors. So that's how we find the factors of the polynomial functions, given that we do not see any pattern from the polynomial. So what we will just do is move out the GCF and then divide the polynomial by the GCF to obtain the next or the other factor. Now here, what we will do is we will try to factor perfect square trinomials. Now the question is, how do we define a perfect square trinomial? Now, the left side of the equation here, class, is a perfect square trinomial. Take note that the first term and the last terms are perfect square. So how do we define a perfect square expression? So expressions like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared are perfect squares. So this is 1, 4, 9, 16, 25. So the right side of the equations are perfect square expressions. With algebraic expressions, so these are perfect square expressions. X squared, y squared, b to the fourth, c to the 20th, d to the 100, e to the 10,000. As you can see, class, the exponents are even numbers. So with algebraic expressions, consider the exponents. Are the exponents of each variable even? So if your answer is yes, then we consider that the expression is perfect square. So going back with the example here, the left side of the equation, we know that the first and the last terms are perfect square. So that is one characteristic of a perfect square trinomial. Another, when you extract the square root of the first and the last term and double that, the result should be the middle term. But the question here is, how do we extract the square root? Well, going back with these figures, this, as what I was saying, the right side of the equation is a perfect square. Extracting the square root of a perfect square expression will result to the base of the left side of the equation. So that's the square root. But as regards to the expressions, algebraic expressions like square root of x squared is x, square root of y squared is y, square root of x to the fourth is x squared, square root of y to the 100 is y to the 50th. So take note that we just divide the exponent of the radicand by 2. So that's how we extract the square root. Okay, so for instance here, we know that the square root of x squared is x and the square root of y squared is y. Now, the last condition for us to consider the expression as perfect square trinomial is that when we extract the square root of the first and the last terms here, and then we double as we get the product, it has to be the middle term. So square root of x squared times square root of y squared times 2. So that's x times y times 2 will give us 2xy. So if the two conditions are satisfied, then we can say that the expression is a perfect square trinomial. The next question is, how do we get the factors? We will just simply extract the square root of the first and the last terms, which are both perfect square expressions, and we write this and we separate the square root by whatever the sign of the middle term. That's why we make use of the plus sign here and then quantity squared. So that would be the factors. Now, this pattern, as you can see, is familiar because the right side of the formula is actually the square of binomial. So we have made use of this in special products, particularly square of binomial. And the square of the binomial or the square of a binomial class will always be a perfect square trinomial. Okay, let's try to factor completely each polynomials here, but let's find out if each given here is a perfect square trinomial. So we can make use of this pattern. So 25x squared is perfect square as well as 49. Now square root of 25x squared is 5x while square root of 49 is 7. Their product, like 5x times 7 is 35x times 2, lead us to the middle term. So this is a perfect square trinomial. So the factors will be square root of the first term, 5x, plus, since this is plus, square root of 49, 7, quantity squared. So these are the factors. Number 2, so this is perfect square, and the square root of 64 y squared is 8y. Well, z squared is also perfect square, and its square root is z. When we get the product of 8y and z and we multiply that by 2, will result to the middle term 16yz. So therefore, this is again a perfect square trinomial. So the factors are the square root of the first term, 8y, minus the square root of z squared, z quantity squared. Why minus? Because this is a minus sign. So these are the factors. For number 3, 121b to the fourth is a perfect square expression, and its square root is 11b squared, while square root of 1 equals 1. Their product times 2 would be 22b squared, which is the middle term. Again, this is a perfect square trinomial. And the factors are the square root of the first term here. So we have 11b squared plus, because this is plus, square root of 1, which is 1, quantity squared. So these are the factors. For number 4, we have square root of 81 for a while. Oh, so we'll get, the square root of 81w squared, and that is 9w. Square root of the last term 4 is 2. When we multiply 9w and 2, we'll have 18, and then times 2, it's the middle term. So this is a perfect square trinomial, and their factors are square root of 81w squared, so that's 9w, minus square root of 4 quantity squared. So these are the factors. For this one, so this is also a perfect square trinomial, and the factors are square root of 36t squared, this is 60, minus square root of 25 quantity squared. Now in number 6 class, obviously, this is not a perfect square trinomial, the first and the last terms as well. So maybe we can work on the GCF, and I think the GCF is 2m. So we will divide all the terms by the GCF. So 50m x squared divided by 2m. So we have 25x squared. 20mx divided by 2m, we have negative 10x. And then 2m divided by 2m is 1. Now, this is not yet the final factors class, since the second factor here is still factorable. So we have to work on the factors, and this is a perfect square trinomial. So the final factors would be, so you have to write the first factor here and then work on the factors of this perfect square trinomial. So we will extract the square root of the first term and the square root of 1. So this is quantity, square root of 25x squared, 5x, minus square root of 1, quantity squared. So these are the factors. Never ever forget to place the GCF as the final factor. And if this is your final factor, this will be marked wrong, because again the second factor is still factorable. So this must be the final your final factor. Again, this is not a perfect square trinomial. So this must have a GCF, and we have to move out that GCF. And the GCF class is 6x squared. So we will divide each of these terms by 6x squared to obtain the next factor or the other factor. So 24p squared x squared, when divided by the GCF, it's 4p squared. And then 24px squared divided by 6x squared is minus 4p. And then 6x squared divided by 6x squared is 1. Now, this is a perfect square trinomial. So we have to factor this out. And this is not yet the final factor. So we'll copy the GCF as one of the factors. And then we will extract the square root of the first and the last term. Consider the minus sign here and then quantity squared. So this is quantity 2p, which is the square root of 4p squared, minus square root of 1, which is 1 quantity squared. So these are the factors. Again, number 8 is not a perfect square trinomial, though 64 and 100 are perfect squares, but their variables are not. So we will move out the GCF, and the GCF among the three terms here is 4v. And we will divide all of these terms by the GCF 4v. So we have 64vx squared divided by 4v equals 16x squared. Now, 160vx divided by 4v is 40x, while 100w rather divided by 4v is 25. Again, class, this is still factorable and this is a perfect square trinomial. So what we will do is copy the GCF, which is considered as one of the final factors, and then the other factor is the factors of this perfect square trinomial. And that is obtained by working on the square root of the first and the last terms. And then the side must be plus of the binomial. So 16x squared, when the square root of 16x squared is 4x, plus the square root of 25, 5 quantity squared. So these are the factors. Though I will not give you your next activity, I will not no longer upload activities in the MS Teams for this topic. This will be part of your quiz number 3 as well as in your practice set 1. So I hope you are able to understand the discussion, and see you then.